Atoms are the smallest unit of matter. Atom consists of subatomic particles such as protons, electrons, and neutrons. Now, let us look at the arrangement of these subatomic particles in an atom. Different models were proposed to explain the distribution of subatomic particles in an atom. Of these models, J.J. Thomson and Hans Rutherford are of great importance, and we will study about these models today. Let us discuss first about J.J. Thomson. The location of electron and the proton in an atom was unknown before 1898. J.J. Thomson proposed a simple model to an atom known as Thomson's atomic model. Thomson considered an atom with radius of 10 to the power minus 10 meter to be a sphere of uniform positive charge into which the negatively charged electrons were embedded like seeds in watermelon. So, this model is also known as Thomson's watermelon model or plum raisin pudding model. This model could not explain many practical and theoretical facts explained by the results of alpha particle scattering experiment performed by Hans Rutherford and thus discarded soon. Also, it could not explain the stability of atom, that is, how positively charged particles are shielded from negatively charged particles without getting neutralized. In order to validate Thomson's atomic model, Hans Rutherford and his co-workers performed gold foil or alpha particle scattering experiment. Before we proceed to alpha particle scattering experiment, let us understand what is alpha particle. It shows other particles emitted from same source and its few properties. We know certain element radioactive substance emit radiation on their own, and this phenomenon is known as radioactivity. Emitted radiation are of three types: alpha rays, beta rays, and gamma rays. Alpha rays is symbolized by 2He4++, where 2 plus is or plus plus is positive charge, 4 is atomic mass, and 2 is atomic number. Beta rays is denoted by symbol -1E0, which consists of negatively charged particle. Gamma particle are high energy radiation which do not consist of particle and are neutral in charge, denoted by symbol gamma 00. Here, penetrating power of different rays are explained properly in the video, which shows alpha rays is least penetrating and gamma rays is the most penetrating, which is 1000 times more penetrating than alpha rays. Now let us understand alpha particle scattering experiment. In this experiment, he bombarded a thin sheet of gold 0.0006 cm thickness with energetic alpha particle, positively charged particle equivalent to helium ion He2+, which were obtained from radioactive substance. If Thomson's model was correct, all alpha particles should pass through the gold foil almost undeflected. This is because entire mass and positive charge is uniformly spread throughout the atom. However, the observations were different. Three types of alpha particles were observed after scattering experiment by an atom contained in a gold foil. 1. Most of the alpha particle, about 99%, passed straight through the atom without deflection. Some of the alpha particles deflected through different small angles. Few of the alpha particles, about 1 in 10,000, were deflected by as much as 90 degree or even larger angle. 1 in 20,000 alpha particle reflected or returned back suffering deflection of 180 degree. From this observation, Rutherford concluded most of the space inside an atom should be hollow or empty since most of the alpha particle pass without deflection. There should be heavy positively charged body at the center of an atom as some of the alpha particle were deflected through different angle by 90 degree or even larger angle. This is because a positively charged center repel positive particle. The nucleus of an atom should possess considerable mass since it has reflected alpha particle of considerable mass. The volume occupied by the center or nucleus should be very small in comparison to the volume of sphere or atom because number of alpha particle deflected through 90 degree or even larger angle is very small. These are the conclusions made from alpha particle scattering experiment. According to this, a single atom can be considered as consisting of positively charged particle in center named as nucleus. We will continue this topic in next video. Thank you.